Bismillahirrahmanirrahim. Welcome to Pakistan International School Taif. This is Fayaz Manchari, Professor of Chemistry. So, dear students, we start with number 2 today. And this is, I think, lesson number 6 or 7. So, this is the first year class, Chemistry, and the new chapter is Atomic Structure. So, when we are talking about the atomic structure, we have discovery of electron. Discovery of electron by using discharge tube. By using a discharge tube, we have to write an experiment for the discovery of electron. So there are 3 scientists involved for the discovery of electron. Number 1 is J.J. Thomson. Number 2, Michael Faraday and Sir William Crookes. So these are the 3 scientists. They perform their experiments independently and discover the electron by using the discharge tube experiment. Now in the discharge tube experiment, what they took? They took the discharge tube. This is a discharge tube. And this discharge tube is a cut where vacuum pump. I will tell you about what's the use of vacuum pump. And these are the electrodes. This electrode is called cathode. Cathode has a negative charge. And this electrode is called anode. Anode has positive charge. And inside, first of all, they put air inside here. And these 2 ends of the electrodes and cathode and anode were connected with very powerful battery. So here battery is connected and this voltage up to 5,000 volts, dear students. So these 5,000 volts were applied inside the air. There is the air inside here. Okay? So at the normal pressure, 1 atmospheric pressure. So when they pass electric current, there are no result. Nothing will be happening. The current is not passed through the air at 1 atmospheric pressure. About 5,000 volts they apply the electric current. When this failure, what they done? They remove the air from the discharge tube. This is made up of glass. This discharge tube is made up of glass. So then what they put? They put the gas. Suppose they put hydrogen gas or helium gas. Any gas they put inside. Oxygen gas. So when they put any one of the gas, air is removed. Again they apply the electric current through the battery by using 2,000 to 5,000 volts electric current. Again, they fail to see the conduction of electric current through the gases. Then they observe that at normal pressure, 1 atmospheric pressure is equal to 760 torr. So this 760 torr was applied by conduction of electric current through the air as well as gas. There was no conduction of electric current. Then they were done by using this. I have written here. There is a vacuum pump. So by using the vacuum pump, they decrease the pressure inside the discharge tube. So when they are going to decreasing the pressure, what happens? happen when this pressure reaches 0.1 torr. Very low pressure, you can say. If you not remember this 0.1 or 0.01 torr, you can write at very low pressure. So at very low pressure, they observe from glowing here. Glowing was coming from the cathode, from the negative charge. This light glowing when they observed from the cathode, and it was going travel towards anode. So this glowing was observed from the cathode, and this glowing is disappear when this current, pressure was adjusted 0.01 torr. So this original glowing was going to disappear, and the negatively charged particles, they are going to travel from cathode to anode. Cathode to anode, these particles are going to travel from the cathode and anode discharge to 2.1 article. This is the 2.1 article. So this means that the origin of the negatively charged particles from the cathode terminal, cathode electrode. This is a very important point. You have to remember. Why we call it cathode rays? The name of cathode rays because these rays originated from the cathode. They are origin from the cathode. That's why we call cathode rays, and they are traveling from cathode to anode. So that's why they have negative charge. These are negatively charged particles. And there is a one thing. When these rays are going to strike with the glass, there is a glowing collection. Because different glasses are made up of different materials. Actually, glass is super cooled. It is not a crystalline solid, amorphous. Super cooled. It's a mixture of silicates of different metals. Normal glass is made up of sodium silicate, potassium silicate, calcium silicate. So dear students, when the current is going to pass through at very low pressure and very high electric current is going to be passed, I told you up to 5,000 volts. So these cathode rays are going to be struck with the glass. So glass is made up of some metallic compounds, so sodium metal, potassium metal. So due to the different metals, the different colors are going to be formed. So this is the experiment how the cathode rays were discovered. Again I am telling you, this is the discharge tube experiment. Discharge tube made up of glass. There is a vacuum pump to adjust the pressure. This is the cathode electrode and this is the anode electrode. Cathode has a negative charge and anode has a positive charge. So there is a battery. Negative terminal is connected to negative and positive terminal is connected to positive. When the pressure is normal, 1 atmosphere pressure so there was no conduction of electric current through the air as well as from any gas. So when the pressure was decreased at very low point 1 to 0.01 torr, there was growing, the electric current is going to be passed through the any gas, and the rays are originating from the cathode and traveling towards the anode. It means that some negatively charged rays are going to be originated from the cathode and traveling towards the anode. It means that they are positively negatively charged rays. And these three scientists, J.J. Thomson, Michael Faraday, and Sir William Crookes, they are going to they done the experiment, and they are succeeded to discover the electrons. I think that, this lecture is a 7. This is the experiment, students. You can see in your book, this experiment is given here, and you can see this is the same one. High voltage is going to be applied. Actually, this experiment was done in 1886, 1887, like this one. So, according to your book, the name was given before. We called cathode rays, now we called electron. So the name of the scientist is Stoney. Stoney. In this period, Stoney was a scientist, and he gave the name of the cathode rays, which are called electron. And proton name was given Rutherford. Rutherford gave the name of proton. And neutron, James Chadwick in 1932. So one by one we have discussed. This is the discovery of electrons. So very high voltage, even in the book is written about 5,000 to 10,000 voltage was applied when you are going to pass electric current by using a very low pressure. So it is now very clear that normal pressure, the gases do not conduct electric current. At very high pressure, the gases are going to conduct electric current. So this is the one thing. We discovered the electrons, and this experiment is given J.J. Thomson, Michael Faraday, and also Crookes. So this is the same which is done here. Now students, then there are properties. This experiment is given in your book. You have to read very well. Already I told you, you should have your book. So this is the experiment, and these scientists, and this diagram is given in your book, and I told you this one. Now, properties. Stoney was a scientist. Stoney. Different scientists explain the different properties of electron. Properties of electron. So one by one we have to explain. Number 1, J. Perrin. If you open your book, properties, J. Perrin in 1895. showed that cathode rays are reflected in the magnetic field. Magnetic field, deflected by magnetic field. J.J. Thomson in 1897 proved that these rays can be deflected towards the showing that these are the negatively charged particles. They cast shadow. If you are going to place a object where the light cannot pass through, it's not a transparent. So when the light strikes on the other side, you will get the shadow of that object. So J. Thomson proved that these rays are deflected towards the anode, showing that they are negatively charged particles, as I draw the diagram before, that they are deflecting towards anode. They produce green fluorescence or striking the wall of glass. So here two names, J. Perrin and J. Thomson. Number third, in 1869, Petrov scientist. According to diagram here, I told you already that this Petrov scientist, he placed a object like this one. This object, light is not going to pass. This is a object. Book is a object. Human beings are a because light is not going to pass through this one. Just like you are going to move morning time and also evening time, that you are observing your shadow. So that same thing is that when an object is placed inside and same discharge tube, mechanism is same. When I am talking about discharge tube, you should mind that mechanism is always same. Conditions are always same for the discovery of electron. Conditions I told you at very low pressure, and high electric current discharge tube, the gas is going to be used inside, and there is a formation of cathode rays, and Stoney give the name that these are electrons. So when they strike with the object on the other side, you will see the shadow for this object. And what is the result? This shows that cathode rays, electrons travel in a straight line. Their direction is straight lines. This experiment by using a J. Perrin show that cathode rays, electrons are going to straight line perpendicular to the surface of cathode. There was another diagram which is given in your book. You can see there is the same discharge tube, but what was placed in a discharge tube? Small wheel. Small wheel was there inside. Very small paddle wheel, which is movable, which is going to move just like a small round thing, wheel, which is going to move. It's placed center of the discharge tube. When you are going to make a mechanism, when you are setting the apparatus by using a discharge tube and cathode and anode, maintaining pressure, giving temperature, then you have to apply the electric current, very high electric current. Electrons are going to be, cathodes are going to be passed here. So when these cathode rays are striking, so this is going to be moved very fast. When the cathode rays are striking paddle wheel, so this paddle wheel was moving very fast. So from this experiment, this was observed that, verified that these rays are material in nature, particle in nature. Cathode rays are particle in nature, material in nature. Another thing, they can produce X-rays. We have a separate topic for the discovery of X-rays. I'll explain. They produce heat when they fall on the platinum. They have energetic, they have energy. That's why the material is going to be hot, and they can ionize. These are the ionizer of the gases. When we are going to pass these electrons, or we can say cathode rays, to the gases, gas is going to be ionized. So we will do for the discovery of proton. Discovery of protons, I will explain this in detail. And also they can make a chemical change when they are going to pass through any material. So now these were the properties. These were the properties of the electron. Now, J.J. Thomson he performed his own experiment and was able to calculate the charge to mass ratio of electron. 1.7855 into 10 raised power minus 11. Coulombs per gram. 1.75 588 10 raised power minus 11. This is a capital C, coulombs per gram. This is called a charge to mass ratio, or we can say coulombs if you want to convert, because the mass of electron is a very, very small indeed, very small. So you can express in the kilograms, coulombs per kilogram. So this experiment was done by the J.J. Thomson. So dear students, the experiment was done by him. There was a discharge tube. He constructed his own discharge tube. The mechanism was same, already I told you. What happened? In absence, first point, in absence of electric and magnetic field, he put a spring. He put a spring here, like this. This was a spring. This point was A, center was B, and this was a C point. This is a spring. So in absence of electric and magnetic field, by using the discharge tube, the electron strike. Electron strike at the point B, center, straight. It means that they travel in a straight line. Now this is in the absence of. Now, then under the effect of electric field. Electric field. Electric field means here positive and here negative. Anode and cathode. Electric field. Positive and negative. So when he passed the electrons through the electric field, under the influence of electric field, so these electrons were going to strike point A because electrons have negative charge and this is a positive, so they deflected towards positive. This is the influence of electric field. Now, similarly, they strike a point C under the influence of magnetic field only. This is the electric field here absence, and this is only magnetic field is going to be applied. So similarly, they strike at the point C under the influence of magnetic field. Now there is one thing more. J.J. Thomson balanced, equalized the strength of electric field and magnetic field, both. He balanced, equalized the strength of electric field and the magnetic field. So when these are going to be equal, what happens? Their effect is going to be cancelled. The effect are cancelled. So then again, these cathode rays were strike at the point B center. Now electric and magnetic field were adjusted in such a way that electron again strike at point B. So by using all these things during his experiment and experimental data, he was able to calculate the charge to mass ratio of the electron, not independently charge of electron, not independently mass of electron, but he was able to calculate the charge to mass ratio of 1 kilogram of the electron. If we have a 1 kilogram of the electrons, so this is a charge 1.75 into 10 raised power 11. 1.7588 into 10 raised power 11 coulombs per kilogram. This is a charge on 1 kilogram of the electron, students. He was succeeded to calculate this by comparing the strength of two fields. He determined the E over M value for the electron, which was 1.7588 10 raised power 11 coulombs per kilogram. This means that if we have a 1 kilogram of the electron, this is a charge for this one. So dear students, this is the experiment for the calculating charge to mass ratio of electron. So the next lecture, inshallah, I will give you about the discovery of how the charge only independently, charge of electron was calculated and determination of mass of electron. In the next lecture, I will explain about this. Thank you.